Hello, everyone, and welcome to this Carmenta webinar on the safety and efficiency of UAS operations. I'm really happy to see so many of you signed up for this. It's always great to see an interest in the new tech that we launch. I know that some of you already know me. My name is Tobias Moberg. I'm the CTO of Carmenta. I'm based in Sweden, here in our Stockholm office. I will soon hand over to Luke and Herbert, who will run this webinar. But before I do that, I'd just like to take the opportunity to say a few words about the company and the core technology that we provide. So Carmenta, we're a software company. We provide components for handling geospatial information in various kinds of mission-critical systems. We're headquartered here in Sweden, but as you can see, we've got offices around Europe as well as in the United States. And this allows us to work really closely together with our customers to ensure that our technology can support them in the best possible way. So the technology is designed to visualize and analyze geospatial information. And when we talk about geospatial information, we're not only talking about the static data, the satellite imagery and the elevation model and so forth. We're also talking about all the dynamic information that you want to pull into your map, be it live sensor data coming in from a radar or maybe a video feed being downlinked from a drone. We are really good at pulling all this together and using it for visualization and analysis to help the end user understand what's going on in the map and how to operate in the environment. The technology can be deployed in a range of different ways. You can build web-based solutions using our technology. And of course, the service-based offering that we're presenting today is a good example of that. But you can also integrate the technology into mobile apps, as well as traditional applications running on Windows and Linux. And if you're interested in learning more about how you can integrate our technology, feel free to reach out to us after this webinar so that we can discuss that more. So with that said, I'd like to hand over now to Luke Silk and Herbert Schiller in our UK office, who will take you through the rest of the webinar. I hope you enjoy the show.
Hi everyone, welcome to this webinar of Carmenta UAS Services. I'm Luke Silk, one of the software engineers at Carmenta Geospatial Technologies.
I'm Herbert Schiller, also one of the software engineers for Carmenta. And today I want to start in this webinar by saying what we're going to cover here today. So we'll have a quick look at the US market and its potential. Then we will look into the challenges facing US operations, specifically in autonomous systems. Next, we will explore some real-world commercial applications of UAS and how our solution, Carmenta UAS Services, can support your services and systems. Then for those of you who are developers, integrators, system engineers, we will get into the techie stuff, have a closer look into what's inside Carmenta UAS Services, talk about architecture and integration, endpoints, data sources, and demonstrate some of the capabilities. Finally, we will give you more information on how to get started, how to get access to the services, and open at the end for a short Q&A, depending on how we get on with time.
I just want to summarize by saying this webinar matters because the UAS industry is at a critical point. The potential is enormous, but so are the challenges. Whether you're a service provider, a system manufacturer, or a systems integrator, you're facing complex technical and operational challenges. And that's not even to mention regulation. But these challenges are also opportunities to innovate, increase efficiency, and to unlock new possibilities in UAS applications. So hopefully we can help you along that route with some of these challenges.
And who is this webinar for? Well, I believe today we will have something for everyone. Whether you're a service provider, a system manufacturer, a system integrator, a developer, I like to believe that there will be something useful for everyone. But ultimately, this webinar is for anyone interested in US operations, wanting to explore the market, the industry, or just curious about it. So let's begin. Okay, so let's have a look at some of the market insights. Now, I don't believe I have to convince any of you in this webinar that US market is growing and presenting some great opportunities for those pioneering it. I'm sure that if you are here right now, you know it because you're either already part of this market or you're trying to get into it. But we thought it would be good to just to give you some evidence of and to back up our claims. So the first piece of data I have for you here is from Markets and Markets, is an American management consulting firm. They published this year an extensive report that really puts the growth of the US industry into perspective. According to their research, the overall UAV market is expected to reach 30 billion by 2025, and it's projected to grow to almost 50 billion by 2029. So that's a compound annual growth rate of 9.9%. So next one I have here for you is for more focused on UAS operators, the European Union Aviation Safety Agency. They published in 2022 that the number of drones operating in Europe is expected to reach 1.5 million by 2035. And this includes an estimation of average of 1 million for leisure use, but 500,000 for commercial and government use. So for operators, that shows that the commercial applications are getting more and more common. So one more for UTM providers, another research published by an American research company. They published recently that for a very important system of the UAS ecosystem, the UTMs, the traffic management systems, a projection of growth of the global market from $900 million in 2023 to $3.3 billion by 2030. So that shows that we are expecting our skies to get increasingly more and more crowded, and the importance of such traffic management systems. And lastly, since Luke and I are developers, we thought it would be a good idea to include something here for ourselves to justify our bosses why we're here. So the drone software market is predicted to reach $5.3 billion by 2026, and that's just a couple of years away.
So let's talk about some of the challenges for autonomous UAS. Whether you're flying a single drone or managing a fleet, you're still dealing with real-time data, decision-making, and dynamic environments. The more advanced the mission, the more complex these technical requirements become. There's a lot involved in UAS operations, and depending on if you're planning or executing the mission, we can extract the problem into two separate categories. First is mission planning, and second is mission execution. The mission planning stage is the strategic phase, where we lay out the objectives and constraints of the mission and need to consider things like the weather, the airspace, safety cases, but that's just half of it. We've also got the mission execution stage, or the tactical side of things. Here we're talking about real-time data, real-time moving of the drone, handling dynamic environments, and the dynamic airspace. And for that, we need quick responses and quick decision making. But regardless of which stage you're in during your mission, either it be at the planning stage, where you'll be building your safety case and considering regulations, things like the airspace you're operating in, the vertical clearances, the safety distances. You might have to maintain away from other airspace restrictions or no-fly zones. Or if you're at the execution stage, making sure you always have visual line of sight, making sure that the UAS is operating within its intended flight path and safety case, and complying with any safety distances and regulations. You will have to consider the regulation in place to demonstrate that you can operate in a safe way, whether that's autonomous, BVLOS or VLOS. In VLOS flights, pilots have the ability to understand the environments. But beyond visual line of sight and autonomous systems, they need to rely on sensors and geospatial analysis, providing this situational awareness. And it's this situational awareness that will be fundamental when we step into the bounds of autonomous operations. I'm not going to try and define what autonomy is, whether it's automatic, automated, or autonomous. Depending on who you ask, will depend on the answer that you get. But either way, situational awareness is crucial when systems have to consider air-to-air and air-to-ground deconfliction, as well as define and control airspaces and so on. But regardless of all these challenges, we need to focus on maximising the opportunities and safety of these operations. So how can we use these advanced capabilities and push the boundaries of what's possible with UAS technology? So let's talk about commercial applications for real world scenarios, because at the end of the day, we're not just flying drones for fun in the commercial world. So we're going to highlight the objectives and discuss how drones are commonly used and present a better way and improvement to these operations. The first obvious one that's very popular is aerial surveying and inspection. Whether this is for agriculture, photogrammetry, search and rescue, or roof inspections or perimeter surveillance. The goal here for the drone operations is to capture that data, and what you want to do with that can come later. Next, we've got route deconfliction and optimisation. So this real world use case for this could be things like delivering drones or packages, medical supplies, takeaway deliveries in the future. We don't know how that will go, but it's very important to make sure that the route is deconflicted and optimised to operate safely. Finally, there's traffic and airspace management, which is going to be has a very big part to play in the world of UAS operations going forward.
Right, so let's have a look at our solution, what we're offering here. So Carmenta UAS Services is a set of geospatial services that can support UAS systems. Now, these services provide crucial functionalities for safe, efficient, and compliant drone operations. So let's start by having a look at what we call the elevation service. So this is used for retrieving various types of data from given geographical points or areas. So just to give you a few examples of how it can be used, you could use it, for example, to determine the exact height of takeoff and landing sites, calculate terrain profiles along a flight path, identify potential obstacles based on elevation changes, and much more. Next service we've got is the obstruction service. This can be used to perform line of sight analysis, identify obstacles, and conduct obstruction analysis. So a few examples to ensure unobstructed communication between the drone and ground control, detect potential collision risks along a flight path, optimize sensor placement for maximum coverage, or even to determine visual line of sight. Next, we have the pattern service. So this can be used to generate efficient flight patterns based on the specific camera specifications, like your camera lenses, and on the mission requirements. So on what you're actually trying to look at. So this can be used to create optimal search patterns for search and rescue operations, design efficient survey patterns for agricultural monitoring, or even to generate inspection patterns for infrastructure assessment, or actually do your perimeter surveillance. Next, we have the routing service. That can be used to calculate optimal deconflicted routes considering various factors such as your airspace restrictions, obstacles, and other flight paths. So some examples we could use to plan the most efficient delivery routes in an urban environment or even on other complex environments, and generate safe flight paths for beyond line of sight operations. So dynamically reroute drones to avoid newly detected obstacles or restricted areas, and so on. Next, we have two services combined called the polygon and volume services. These can be used to apply various operations on 2D and 3D geometries, so that will enable complex spatial analysis and manipulation. So for example, to define and manage no-fly zones or no-fly volumes, calculate intersection of flight paths with restricted airspaces, determine the volume of airspace available for operations, and so on. And lastly, just wanted to highlight some of the services that are intended for future development, but just so you have a taste of what's coming up. We have something called translation service that will be used to convert different coordinate systems and spatial references. Triangulation service to determine precise locations based on multiple reference points or bearings. And lastly, our sensor services to optimize sensor placement and analysis for coverage, sensor coverage for various applications.
Okay, so if I just share this window, that's a demo application we've built. If I just create a new mission, I could just call it elevation service. We can leave the default parameters. If we select a takeoff and landing spot, anywhere really. We could just choose a couple of waypoints to demo some of this surface at point functionality. So here we've got a very simple route. This is a 2D application with no elevation data in it, and just visualizing satellite maps. But if we select this first waypoint, what the application is doing is actually calling the elevation service in the cloud and getting the elevation data. So as you'd expect, along the river, the surface value is very similar to the AMSL value, above mean sea level. So that's the same for waypoints 1 and 2. But waypoint 3, if we move this along a little bit, there you go. You can see that the waypoint is actually the same AMSL value, but your vertical clearance is a lot less because it's a lot lower above the surface of the building. So we can probably put that into a building somewhere there. Yeah, there we go. So as we're moving that around, you can see the surface level is changing very quickly. Something else you can do is get the surface in a polygon or higher surface in a polygon, for example. So if I just draw a simple polygon, we've got a geofence here, and what we've programmed it to do is to go off to the API, and as you draw that square or polygon or whatever shape you want, it will send those points to the endpoint and ask what the highest object in that area is. So that's really useful for things like return to home altitudes. If you lose communications and inside your operating area, you'll want to make sure that the drone does something safe. And if the drone is programmed and to go back home, you might want to ascend to a certain altitude. This way you can ensure that you'll clear all of the buildings in that area. Obviously you can't really see that that's a relevant altitude, but there is some other API calls in this elevation service that can be used. So we've got geodata here. What that actually calls is the endpoint surface in polygon. So you can actually draw a polygon, and there we go. Very quickly, almost immediately, you're getting all of the surface inside the polygon. So you can see there. So that outer red box, that geocage, is the top height is set to the top of that building, because we asked for it returned a single value, but when we ask for the surface, we get all of the buildings, all of the trees that you need to avoid. What we can do is calculate a route based on those waypoints that you're interested in. I'll just let this play and circle around, and I'll talk around some of the other functionality that's happening as we're getting updates from the drones. You can see there's a little drone around here simulating flying the route, and that's just going to go around and repeat for this demo. But if I just add this simulation mode here, what we've got is we know where the pilot is. Well, in this example, we've just assumed it is actually the takeoff and landing spot, but it can be specified in the API. So here, what we're actually doing is in the top left, you can see whether the pilot, whether the drone is within pilot line of sight. So this could be a 2D application. This can be for autonomous systems. This could be for UTMs, for example. It's just providing that functionality. As the drone is updating its position, we are calling the API in AWS and asking if the pilot can see the drone from that location. In the same call, you can ask for just the line of sight, or you can ask for a vector line of sight from point to a point, a single point. So in this example, we're actually asking for the vector, which is providing you yes or no, you can see it, as well as the distance, the bearing, and the pitch. So if you needed to point sensors to capture that information, or to point a camera at it, the API will also give you that position anyway at the same time. So obviously you can also see this is still some of the altitude, the elevation API is also being called. Obviously it's the altitude above takeoff is not changing that much because we didn't change the waypoint heights, but the altitude above surface is continuously changing as we're flying over buildings and things like that. So you can do this to monitor your vertical clearance or safety distance from objects. So that's some of the functionality in the obstruction service. I can show you a bit more as well. So here we've just cleared the screen, cleared of all the elevation data, and here we've just got a slider where we can set our safety distance for what we want. So let's say you want to know of all objects within 50 meters of your current location. Let's go back to simulation mode here, so you can see all the other information at the same time. So here you can see those. We're highlighting the surfaces of the areas that are within that distance. So as you're flying over, as you're getting closer to buildings, there's more risk and more surface that you can actually, potentially collide with, that you want to make your pilot aware of. Or it it could be a simple yes or no to warn them that they've breached regulations and they're within certain safety distances. So it just provides you that capability to do this in real time. And you can see this isn't faked or anything, especially when I click the wrong thing. So if we start changing the routes, for example, the route changes, and you'll still see that all the calculations are happening. And as you go over different areas, you're getting different risks, and you can visualize that or make decisions based on that information, however most suitable for your use case. Okay, so I'll move over to this web demo now, because if any of you already have access to the trial, or any of you are going to sign up for the free 30-day trial, this is the application you'll actually have access to. So it doesn't have all. Obviously the API has all of these endpoints that you can use, but this web application just focuses on some of the ones that are more common or very difficult to visualize in the API. For example, if you're generating lots of waypoints, whether that's complex routing or for patterns, it's not very nice to visualize a load of latitude, longitude, and altitudes in text. So that's what this demo was intended to do, to just demonstrate that. And you'll obviously all be able to test it out as well if you sign up for the trial. So what we've got here is this pattern service. So this can be used for a number of scenarios, maybe search and rescue, building inspection or surveys, photogrammetry. And the idea is basically, you pass in an area that you're interested in, along with the camera specifications and image requirements. So for example, based on your field of view from the camera and your resolution will determine, how many points you need to cover a certain area. And like the higher the resolution, the further away you can be, for example, and the image requirements. So how much overlap you need. For example, in photogrammetry, you might need a high image overlap to do feature matching, and then the smallest feature. So depending on what resolution you want your end data to be, will determine on how far you need to place waypoints from the build from the place that you want to inspect. So like if you're looking for a person, you can be a lot further away with any camera than if you wanted to take the same camera and look for a hairline crack on a bridge, for example. So it's very much use case specific, and the API allows for that. So here we've got patterns that we can add inspection areas. So let's take familiar London and Tower Bridge. Let's say we want to draw a box over Tower Bridge, and we want to do some sort of search pattern, some sort of inspection pattern. I won't use the elevation data for now. I'll show you what that does in a minute. But if we generate a pattern, here you can see that it's got the camera specifications, it's got the image resolution and feature requirements, and it's placed those waypoints. So if we change this, let's say we want to look at we're looking to detect a smaller object, or we want higher resolution data, we can generate the pattern. That's brought it lower down, and we've got more waypoints to capture that data. In the same way, if we had a high resolution camera, we might have less waypoints, or a lower resolution camera, we might have more waypoints. So all of that's done with the API. So the elevation data, what that does, let's reset that, and there we go. If we want to use the elevation data, rather than fly at a flat altitude, because that might not be applicable for all scenarios. So if you want to do some sort of search and rescue, that might be suitable. But if you need to ensure you're the same height above every object you're flying over, you might not want to do that. So here, for example, we're flying at the same height above each object, or each waypoint. So we're always maintaining that distance from the objects that you're looking down on. But that's not the only inspection pattern or search pattern. So that's parallel, which is quite a basic pattern. But there might be rectangle. Let's remove that because they didn't go higher up. So here you can either, from inside out, outside in, you can go round in a spiral square type pattern to capture that data. And the API is quite similar in the way it's structured using these parameters. There are more parameters in the API if you need to use. So, but this covers most use cases. We've also got line. We haven't got a tool really to draw a line, but this is actually intended to, if you wanted to inspect along a fence line or along a wall or something like that, or a perimeter, you can pass in the points of that line into the API and get those waypoints back. What we've done here, just for ease of use, so we can demonstrate that functionality without creating a tool to draw lines, is we simply use the outer line of this polygon just to show you. So it's not a very exciting search pattern to show in this scenario because we're drawing polygons, but you can see that it follows the line, and so you can offset that angle if you want to. If you need to be inspected at 45 degrees, that's all available for you in the API. Box. So this is where we're coming more into 3D. Obviously, the sensor coverage is calculated in 3D, but we're not really, proper inspecting 3D buildings at this stage. But here we've got we obviously using the elevation service. We know the height of the building, so you don't need to specify that. And we know the camera specifications, the same as before. But what we've done here is, using the faces of it, or those edges of the polygons, we're ensuring the coverage throughout that 3D area. And as with before, we can reduce the resolution and get lots more waypoints, or have less waypoints with a high resolution camera. So you could also use this to play about and see how long your flight paths will be, or to determine what the best camera to use is if you've got different options. So if we want to go for a smaller feature, again, we'll get even more waypoints. And go for a low res camera and looking for a small feature, you can see that you're going to start getting to lots and lots of different waypoints. But it's all dependent on your use case and what you need to do, and what sensors you have available. And the API is flexible to allow you to do any of those things. And what we'll do is show you some of the routing capabilities from Carmenta UAS Services. So this is all available in the API, and can be used for lots of different use cases. The bits we'll show you here is focused on the simple routing, which should be suitable for many use cases, but there are some more advanced routing options if you need. So what we can do here is if we just add some simple waypoints, I'll choose them carefully for when we want to do BVLOS routing. So if we just place some waypoints in a few locations, maybe here and over here. So what you can do is the demo allows you to just put some waypoints. Obviously, it could be anywhere you want. It's not restricted to where the 3D model is of London. It could be anywhere in the UK. You can draw a couple of routes. By default, these are the default options. And when you click calculate route, what that will do is go off to AWS, or if you had a different installation, wherever it's hosted. By default, it's AWS, which anyone can access, which is where this one is running. And as soon as you click calculate points, what it will do is query the elevation service, find out all the obstacles, and find a deconflicted path based on your parameters. You can customize your vertical clearance. So for example, here you can see we're actually quite close to the buildings in this scenario. That's because we haven't specified a vertical clearance. But if you wanted to be 10 meters, 15 meters clear of buildings, you can just simply put that figure in to the API request as part of the routing parameters, and that will avoid those surfaces by that amount. So the route will go higher in this scenario. So in this particular route, by default, what we actually do is traverse on a single axis at a time. So we'll move on the XY or latitude longitude axes independently or separately of the Z or altitude axes, and that's simply just the default, just for drone compatibility, just in case, without passing that parameter, saying you can fly 3D, just in case your drone can't for whatever reason. So it's just almost a fail-safe to support all rotary wing drones. But there's a simple drop down over here. You can actually change that and recalculate the route, and in this scenario you can see that it's going round the buildings instead of preferring to go over the top. Another parameter that we've got here is clear high surface. So what that will do is that will look at ascending and having a preference to ascend and fly higher, basically. It doesn't necessarily guarantee that you'll fly over the top of the buildings, but you can specify that as an option as well. So it's just it just changes the way that the costs are associated with the route. But you can actually manually specify a figure if you wanted to ascend to a certain AMSL value. For example, you could say I want to fly to 100 meters or ascend to this level. That's available in the API as well. But this is just a simple yes or no if it is, and by default it is true. So if we calculate that, you can see it goes up slightly, but it still goes round. If you wanted to ensure it goes up, you could put in a higher value there. At the moment, that's just it just takes the value along this line. So some of the other things that you could do is, if you were interested in line of sight or BVLOS routing, which is typical for most use cases. Obviously, we haven't developed a tool in this demo to actually specify a pilot location. So we've just we're assuming the pilot is at the takeoff position. So it's this waypoint here. And as you can see, is this route would not comply with visual line of sight regulations. You wouldn't be able to see this path along here. You couldn't go around the building this way here. But with the API call, you can pass in a list of pilot or observer locations. It doesn't necessarily have to be one, depending on your operational safety case and what you're allowed to do. So in this demo, we've set that pilot location to be this waypoint, but it could be any location that you choose. So if we calculate that route, you can see it's got a very different route, and it took a few seconds longer. But every point along this route can actually be seen from this location. So we can even prove that by going roughly where it is. You can see that path, and then it comes over the top of the building quite high up, so it ensures that it can always be seen, along and back down, and then the path back takes a different path to ensure it always remains within line of sight. So these are just some of the parameters you can do, and obviously that looks very different and is a little bit quicker. Other things you can do is you can specify restricted areas or geofences, as well as geocages. In this demo, we've actually only added restricted areas. We haven't implemented the functionality in the UI to do this, to specify a geocage, but it works the same way. So you can just draw a large area, and it will make sure that the drone always remains within that polygon volume. So here you can see it's a different route to before. We are avoiding that geocage, and you can customize these parameters. So if you look in the API, you have the waypoints that you want to do. You've got your geofences, you've got your list of geocages. As I said, we haven't implemented that for this demo, and we've also added some of the parameters, but there are other options as well in the actual full API. And if we were to do the same BVLOS routing, it would still avoid the geofence. So as I say, this if we had a demo, obviously if you wanted to put this functionality into your applications, you could actually change where that observer location is. So if you can see observer. This is just for demo purposes. We've just used the same waypoint as the first waypoint, and it accepts a list of observers. So it doesn't necessarily have to all be the same observer, but you've got that flexibility in the API. Obviously, throughout these demos, I've shown you 2D maps and 3D maps on the web demo, but actually there is no requirement for you to visualize these results. So if you wanted to put these, use the results from the API and put them into autonomous systems, as long as that complies with your regulations and what you want to do, that's obviously also acceptable. There's no requirement to visualize all these. These can be for autonomous systems, as well as mission planning, and to actually show a human being what it is they want to do and see.
Let's have a look at the system architecture and how we deploy our services. So Carmenta UAS Services was designed for scalability, reliability, and ease of integration. So we run our services on Docker containers hosted in Amazon Web Services, AWS. It's based on a stateless architecture with shared instances. So that means that multiple clients can use the same instance of our services simultaneously. And for those in UK, we have pre-integrated UK geospatial data into our services. For those wanting to use outside of UK, I'll show you a slightly alternative solution for our architecture. But I just wanted to finish off by saying we have what we offer to you is an API gateway where you can select between using gRPC or a REST API to communicate, make requests, and receive the responses and results for your system. So as I said, just to show you slightly alternative to the original architecture, if you want to host your own or integrate your own custom data or have it in a private instance, we could offer you a private instance within our AWS environment, or you could host yourself on premises, so into your own systems, and we offer then the integration and updates through a repository. So depending on the level of security, the level of customization, the data you want to integrate, we can have different and slightly different architectures to suit your needs.
So let's talk about some of these data sources that come pre-integrated with Carmenta UAS Services. It's from the Ordnance Survey in the UK, and we utilise the DSM, so the Digital Surface Model, which includes all surface features such as buildings, vegetation and other structures. Also, we have the DTM, the Digital Terrain Model, and that includes bare earth elevation with all surface without the surface features like the buildings, vegetation, and other structures that are removed using bespoke algorithms and manual editing of the data, resulting in a terrain model excluding the ground surface. You could also host your own data. So this can be done by hosting your private instance, either locally in the cloud or hosted by us. And that way you can have your own data segregated from the shared public data. So I'm sure you're all keen to get started and start using these services and integrate those into your applications and systems. So where can you begin? Here you can find the QR code, you can scan that on your phone, and you can sign up to the demo, which has also been displayed throughout this video. You can read our documentation, try out the demo, which is hosted online, so you don't need to download or install anything, and no coding required to see some of these functionalities. And you can also get in touch to support. You can see the email address there is uas.support@carmenta.com. So thank you all for listening to us talk about some of the challenges and some of our solutions. Hopefully you all want to get started with the demo, and hopefully we can work together in future on some of your projects. But yeah, thank you all for listening. We'll hang on the line till the end of the webinar and answer any questions or have any discussions. So please feel free to hang on and discuss with us both.
Right. So yeah, we're gonna open up for a short Q&A. We just don't want to overrun. So if you do have any questions, please post on the chat. We'll have a look. Just before it gets asked, I do have a question that I actually want to answer. If you did meet us at DroneX last couple of weeks where we launched Carmenta UAS Services, there was a question that got asked a lot, which is, well, this is all in good, nice demonstration, but how do I get my drone to do what you just showed me, or what actually Luke showed us through the demonstration phase? The point I want to make is Carmenta UAS Services is not an end user application. So it's not your mission planning or UTM solution, but it does support these applications. But that's not to say that we cannot help you with that. So if you do have the need for a full comprehensive implementation that needs a full end-to-end system with an end user interface, we can support with that. If you already have a mission planner, UTM system, or even a command and control, ground control system that you want to help and support to integrate Carmenta UAS Services, you can also reach out and we can also help with that. Carmenta has a department called Professional Services that can provide consultancy and software development support to allow you to achieve whatever you're trying to do with your systems. But it's important to make clear, Carmenta UAS Services, it's not an end user application. It is a set of services, as you saw, that are hosted on the cloud, or depending on how you want to use the architecture, as I showed you as well, it could be deployed in different ways. But nonetheless, it is a backend set of services that you can use. Right, so Luke, do you have anything else you want to add?
No, I think on some of the defense customers that we've got, or potential customers as well, you know, they sometimes want to host this locally, and I know you touched on that earlier, and as well as on the professional services element of Carmenta, that's certainly something that's possible. A lot of defense companies already use our SDK and put some of this advanced geospatial technology into their applications, and this can be used alongside that as well. So they can be used independently or combined and used together. So, and we've got a question. Currently, there it isn't in the roadmap for Carmenta UAS Services to be used inside Carmenta Engine via one of the operators that obviously you're familiar with. But yeah, it's certainly possible. You could use the API either, it could be deployed in the cloud, the one that's launched at the moment with in AWS, or you could reach out, speak to us, and you could have a containerized version that could be run locally. So it depends on the use case and the architecture that's actually deployed in your solution. And I don't know exactly what you're already using Carmenta Engine for. But yeah, it's certainly easy to implement, and people have already been using Carmenta UAS services on top of their applications. So it's an easy add-on that can that can add value and work nicely together. But currently, it's not in the roadmap for Carmenta Engine. Although that just depends on feedback from customers of Carmenta Engine and Carmenta UAS services. But yeah, good question. Thanks.
Yeah, thank you for that. So I think with that, we promised to keep around 45 minutes. We slightly overrun. Obviously, you can watch it again if you need it. This will keep on YouTube. And if you do have follow-up questions, or if maybe we didn't address or clarify anything, please reach out to us. The email we showed, us.support@carmenta.com. Reach out. We can arrange a one-to-one call and go through in more detail. Okay, so I'll let you all go. Thank you again for watching, and I hope you see you again soon.